Hey everybody, welcome back to I Heart Stats. Last time we were talking about the topic of central tendency, and we want to move on from that to something that's a little bit more complicated today. Not a lot, just a little bit. So today we're going to talk about the topic of dispersion. All right. Now the notion of dispersion is actually really simple too. The idea with dispersion is for us to figure out how spread out the data is. We want to know how much variability there is in the data. It could be very little, things could be packed together, or it could be really spread out. Let me give you an example. Suppose you went out and you were doing a survey and you asked people their age, okay? And you went on a college campus and asked people their age. Well, you'd get a pretty tight range of ages. Maybe you'd get 18 to 23 or 24, something like that, or maybe a little bit more, 17 to 25 or something like that. But most of them ages would be packed in that little range. If you went out in the general population and just asked anybody out there what their age was, you'd get a much broader range. You'd maybe get 3 to 95 or something like that. And so the ages would be spread out a lot more, and that data would have a lot more dispersion than the college student data. And that's going to be an important characteristic of the data for us as we go through the course. Why is this notion of dispersion important in the first place? Well, first of all, it can actually help us answer a real substantive question that we might have. A typical example of this would be something that you hear all the time. The rich are getting richer and the poor are getting poorer. Well, suppose that's an actual question. We want to find out if that's true or not. Are the rich getting richer and the poor getting poorer? If I want to answer that question, I can't just depend on central tendency. I can't just depend, for example, on the mean of the income. It's possible that the mean income could be exactly the same over time, but the rich could be getting rich and the poor could be getting poor, or they could be getting closer together. Let me just show you two distributions of how that might look, and you can see what I mean. Okay, supposing in 2004, I went and I found out everybody's income. Okay, and it looked something like this, let's say. Okay, so I have very few people down here with very low income, and I have very few people with very high income, but most everybody is in here in the middle. But up here we have the rich people, and down here we have the poor people. Okay, so then if the rich are getting richer and the poor are getting poorer, the distribution might look a little different. Now the mean might be exactly the same because both ends are moving out. There's more people on the rich end and there's more people on the poor end, okay? And so then maybe the distribution looks a little bit more like this, okay? So now it's higher on both ends, so I've got more rich people and more poor people, so it's stretching out the distribution, and I have fewer people in the middle. So maybe this supports my idea that the rich are getting richer and the poor are getting poorer. But there's no way that I could have told that from just looking at the means, which have stayed exactly the same. Okay? So that's one kind of question that can really actually be answered with looking at dispersion. All right, so in addition to answering an actual research question that we might have, this dispersion notion is a really important characteristic of data that we need to really know about in order to do statistics. Okay, so we'll get into this a lot more later and we'll understand the reasons for it later, but just keep this in mind, okay? When dispersion is low, when things are packed close together, the accuracy of whatever we're doing, central tendency, the mean, is much higher. The accuracy is higher when it's close together. In that case, the central tendency is more typical when everything is packed in together. Let me draw you two other distributions to kind of illustrate what I'm talking about here. So we have very few cases out here, and we have a lot packed in the middle. Everybody's really close to the mean, okay? In that case, this measure of central tendency is a good way of representing our data. It tells us something pretty important about the data. It's very typical. The central tendency, the mean, is very typical of the data. But what if the distribution looked different? What if it looked like this instead? Okay? Now the mean, even though it's still the mean and it's still in the middle, it's still the most typical thing, it's not as good because we have so many more cases out here in this part. So a lot of people are away from the mean, and so because the dispersion is greater, then the central tendency is not as typical, and it's not as good of a measure of the data. Okay? That's going to be very important as we go forward. Okay? So let's try to keep that notion in mind. Low dispersion means we're being more accurate. Okay?